Hi, and welcome back to the channel. So in the last video, we saw how computers store, manipulate, and understand information in binary system. I would like to believe as the pieces begin to come together, you're either enjoying the series and the knowledge of how exactly the computer works, or you're beginning to understand the pleasures and pains of computer scientists when they do programming and computer software development. So, in this video, we continue learning on how to pass instructions to the computer in an easily comprehensive manner and how to easily understand machine code which comes in binary. As you can understand, binary number system usually takes up a large space and it's hard for us as humans to pass code or instructions to the computer using binary. For that, we are gonna need the hexadecimal system, which is the base 16 system. So let's go. So, in order to understand the hexadecimal system, we need to look at the binary system and the decimal system and how they work. So, in our binary number system, we have just two symbols, and once we use up our two symbols, we recycle and we go to the next placeholder, which is the next power of 2. And as you can tell, our binary numbers will quickly grow so large and so fast in a manner that it becomes harder to read and harder to handle. It goes the same way for our decimal system, in which we have 9 symbols, and once we count using all our 9 symbols, we have to move to the next placeholder, which is a power of 10. And that is just the same thing with the hexadecimal system. But with the hexadecimal system, it becomes a little bit more complex because we have 16 symbols. But since we are used to only 9 digits in our counting number system, in the hexadecimal system, we use our 9 digits symbols up to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we also use our letters of the alphabet to make up the remaining 6 letters. So we also use A, B, C, D, E, F. So in our hexadecimal system, our digits include 1 to 9 and the letters A to F. So just like in our binary number system, in which once you use up your 2 bits, you move to the next placeholder, or in our decimal system, in which once you use up your 9 symbols or 9 digits, you move to the next placeholder. Think of the hexadecimal system as counting up to 16 and then moving to the next placeholder, and placeholders are powers of 16. So the first placeholder would be 16 raised to the power 0, which is 1, and the next placeholder is 16, and the next holder is 16 times 16, which is 256. So I'm not going to dwell too much also on the hexadecimal system, but to make it easier for us to understand, in the decimal system, let's count from 1 to 32 in our hexadecimal system, so you understand how it feels when working in the hexadecimal system. So if you remember, in our hexadecimal system, we have each placeholder has 16 possibilities or 16 digits, and we start from our digit 0, and once we get to our digit 9, we continue with the alphabet. So the letter A represents number 10, B represents 11, C 12, D 13, E 14, and F 15. And once we get to 15, the next, which is 16, moves to the next placeholder. And so 16 looks like our normal 10 in decimal system, but that indicates that we have counted through our 15 digits for the first placeholder, and then move to the second placeholder for the 16, just like we move to number 10 for our decimal system, and just as we move to 2 bits for the number 2. From there, 16 will be 10, 17 will be 11, 18 will be 1 2, 19 will be 1 3, and we'll have to go round again till we get to 32, which is F again. So that is 2 0. So that's when we keep going, and just like that, you can easily understand how the decimal system operates, how the hexadecimal system will also operate. But now you see it takes larger numbers easily. So by the time we get to what looks like 10, we're already at number 16, and that goes the same way. It takes a lot of content to make it easy to understand. So it's thanks to this appealing property of the hexadecimal system in reducing binary code, which it's used at the lowest level of computing to give the machine instructions. And at the basic level of the computer, this is used to pass instructions to the computer and also used to understand machine code. Now, machine code is what exactly the computer understands, which is in binary. But for us to be able to understand binary and to be able to pass instructions to the computer, we have to reduce it in a method which is easier for us to understand, and that is known as an assembly language. Please keep in mind that the earliest computers or Turing machines did not come with any software or operating system. So back in the days when you had a computer, you had to program everything. You had to give the instructions on how the computer works and how exactly what it's going to be doing. So this is like the beginning form of code, and the process of translating hexadecimal into binary is known as assembly language. And in our assembly languages, we have like operands and operations, which we have encoded in a manner which we can just pass as instructions to the computer. So let's take a look at an example of assembly language. You have like the code move R0 to 2E. So this instruction here is just a simple assembly language code, and what this says is we are moving the hexadecimal instruction into a registry number 2. So this is like allocating data to a particular registry for storage or for manipulating the data later on. So we have instructions and we have our hexadecimal, and this is like the elementary form of assembly languages. Now, assembly languages are just second generation languages, which is like saying one step away from machine code, which is binary. So this is the lowest level of coding, and sometimes today people still use this method because it's specific and it's efficient, but because we speak in simpler languages and we use simpler number systems than the computer, we have today more sophisticated languages for us to use to pass instructions to the computer. And these sophisticated programming languages have been created. While they may differ from one another in terms of ease or syntax, they are all doing the same thing at the very basic level. And for them to be able to function, they pass code in a manner which is then translated to machine code, and they require some kind of translation into low-level machine code, which is also known as a compiler. So most of the languages that we use today, which are higher level machine programming languages, they have to be translated to machine code, and this is done by some kind of a compiler. So again, the computer can only process information in machine code, which is in binary format. However, for us to be able to pass these instructions to the computer in a way which can be translated into machine code, we use assembly language, and assembly language is just encoded in hexadecimal and has operands and other methods which we can use to pass the instructions. And this translator is also known as an assembler. So assembly languages are the second generation, like one step away from communicating with the computer, and these are like low-level machine languages. But it doesn't mean the assembly languages are still easy. They just facilitate work, and because us humans, we need to do a lot of work in encoding and passing these instructions, we have today higher level languages, up to third generations or fourth generation languages, which we can use to encode and pass informations to the machines. So I'll end there for now, hoping that you're able to digest all the information. And this is very, very important, because I have personally witnessed a lot of friends lose confidence and fail to progress in computer science or information technology or programming or any form of like software development, because they are confused over which particular language to use, where to start, what to do. Like, there's always something that seems better, but if you look deep and you look at the very essence of what you're doing, it's all the same. So thanks very much for watching and for supporting the channel. Please like the video, share, and give me feedback on what you think, and subscribe to the channel to get more information immediately we drop new content. So thanks very much for watching. Until next time, bye bye.